So welcome to the 38th lecture, and today I'll start with the next unit. First unit was of number system. Second unit I started with the semiconductors and basics of PN junction diode, and rather first unit. And now this is as per your syllabus. I'm starting with unit second, or the second unit of your syllabus. Now this unit is about mainly about a regulated power supply, or the components of a regulated power supply. Now what do you mean by this regulated power supply? Before I come to this regulated power supply, let's talk about this term power supply. What do you mean by power supply? Simply an electrical circuit or an electrical system which supplies some power, some electrical power. A system which supplies an electrical power is called a power supply. Now when I talk about a regulated power supply, what do you mean by regulated? Regulated means which has a commanded one, you can say. Regulated to certain value, fixed to certain value, that type of power supply is called a regulated power supply. That is, it has some commanded, it cannot deviate from certain value, then we say that it is a regulated one. Now what happens that what about this, before I come to exactly to this regulated power supply, fixed power supply you can say, commanded power supply you can say. Now what happens that the power supply that we receive in our homes, in our residence, is a AC one from any power grid, is a AC one. Now most of the electrical appliances that we use, especially in the electrical circuits, or which are the motherboards with some you say that any motherboard, if you have this motherboard and which is a made up of semiconductor especially. Now all these motherboards or electrical circuits, they need a DC or a fixed DC, rather not only DC but a fixed DC, or we say that we need a regulated DC, a commanded DC. Means, for example, if you have seen the adapter of your mobile phones or adapter of your charger, you need 5 volt DC for this. A charger you use in order to charge your mobile phones, generally it is to 3 to 5 volt DC charger is there. So for certain electrical appliances or many electrical appliances, you require a power supply which should be a fixed one, which is a regulated one, and we need a DC here. So our focus is now mainly on a DC power supply. That is, our main focus is on that kind of supply which is providing a pure DC to you. Suppose I say that this is time and this is the voltage. Suppose I need a 5 volt, for example, for an adapter for your laptop. I need a 5 volt, means the output of your adapter should supply constant 5 volt with a change in time. On the other hand, the type of signal or the type of electrical signal or the type of electrical supply that we receive in our households from any power grid is this type of power supply. That is, this is a AC one. Of course, this is time, and if there's a voltage, I say we get this type of voltage here, that is called a AC one. So our aim in this is to obtain this kind of function, this type of function from this function. That is, I need a regulated DC power supply from this AC power supply. That is my main interest, and I need the complete power supply for this. Now if I look at the blocks of a regulated power supply, that is, if you have power supply, look at the block diagram. I call it a block diagram. Power supply, I'll start with a block diagram of this power supply, of this regulated power supply. You have a AC mains here. Whatever you're getting at your homes is the AC mains. Alright, and first of all, in a regulated power supply, we use a transformer here. This block is for a transformer. Followed by another block, that is a rectifier. We call this as a rectifier. I'll just brief them one by one. After rectifier, another block means these all are electrical circuits here. After rectifier, we use a filter. We use a filter here. And then another block, we call it a regulator. This is a regulator. And finally, this output is given to any load here. This can be any load. This is a load here. Load means it can be any appliance here, which I treat as a load. This load can be your TV set, it can be your mobile phone, it can be your laptop. We name this as a load here. So I need from this, look at this. This at AC. Here I am getting this AC here, if you see. What I obtain at this point is from the grid or to your households is this AC waveform here or this AC supply here. Now this transformer is either used to convert this either to step up or step down this AC signal here. That is the amplitude of this, and accordingly you must have done in your junior classes your transfer. Let's talk about this transformer first of all. Talking this part. This is a transformer. What I obtain from this what I get from this transformer is this AC here. Suppose I have this AC here. Assume this to be of constant magnitude. Let's make it this way. Now this transformer, what it does, if I have this AC here, there are two possibilities. Either the magnitude of this will be lowered down in this way, this signal, or the another possibility is that this amplitude is magnified. It is like this. So accordingly, this transformer is known as either this is called step down transformer. Either step down or this is called a step up transformer. Although mostly in laboratories or in our household circuits or in most of the electrical appliances, the type of transformer that is required is a step down transformer. So very first function of this transformer is to step up or step down the AC which we obtain initially. The very first thing is that. So, and it can be either a step up transformer or a step down transformer. Let me discuss little more in detail, although you know all these things already. What is this actually? What this transformer is there? You have an inductive core. Like inductive core. And some turns, copper turns out of copper wire, you take it here and in this way. Now, these turns of copper wire, this is the input side. Suppose I say that the turns on this side is N1 and the number of turns on this side is N2, and if the voltage here at input is suppose V1 and this voltage is V2. Now depending upon this N1 and N2, you have a relation you must have done that V1 upon V2 is equal to N1 upon N2, or I can say that the output voltage, suppose I say that this is the input here of a transformer and this is the output of this transformer. So this V2, this implies that this V2 is equal to, you can find this V2 from it is N2 upon N1, N2 upon N1 into V1. Now depending upon this, I am interested in the output voltage. If this output voltage, I want this output voltage less than the input voltage, then this value of N2 upon N1 should be less than 1. So for step down transformer, N2 upon N1 should be less than 1. N2 upon N1 should be less than 1, or I can say that N2 should be less than N1 from here. That is the secondary winding. This is called primary. One more thing. This is called the primary side or the primary winding, and this is called the secondary. Although it's a revision for you that you have already done it in your previous classes. So very first part is this transformer. Generally we have step down transformer which converts a high voltage signal into a low AC voltage signal. Remember that this transformer is a AC to AC converter. Now what this rectifier does? Second part is this rectifier. Suppose I assume that here this AC is converted to another AC. Now this rectifier, what this rectifier does? Next block is this rectifier. This is the output of transformer where I get a AC. The second stage, output of the rectifier where I get this AC, and it is input to this rectifier. I am taking only this section here. So this is your rectifier. So the application of this rectifier is to convert this AC, not only DC, but it converts this into this type of DC, a pulsating DC. This DC is called a pulsating DC. Pure DC is like this. Pure DC is like this. Means this is having the ripples here. This is having certain AC ripples. So this is a rectifier which converts this AC into a pulsating DC. Now further, when this from this rectifier, this is given to a filter. Now what this filter does actually? I am interested in this kind of DC actually, and I'm at this stage I am obtaining this pulsating DC. So what this filter does, it gives me a waveform of something like this. Not a pure, I am interested in this type of waveform, but it provides me a waveform of this nature, a triangular shape. That is, it removes the pulses or the ripples, AC ripples from here. So the main function of this filter is to remove the ripples. It removes AC ripples rather. It removes the AC ripples of this. And finally, after this filter, as I said, that this is given to a regulator. We'll discuss them in detail, all these parts. A regulator. Now this regulator, it provides me a fixed voltage. It provides me a fixed output voltage here. So initially I have this transformer here. Before this there is a transformer. Followed by a rectifier. Then you have a filter and a regulator. This transformer, it either, if I come to this part again. This transformer, it either steps up or steps down the voltage signal, the input signal, whatever you obtained here. Then this stepped up or stepped down. Although 99% of cases we have this step down transformer for our household appliances. It is step down here. This signal is stepped down by this transformer, and this rectifier, it converts this AC into a pulsating DC. This converts this into a pulsating DC. Now this pulsating DC, further I am interested in this type of AC. It means that it has some AC ripples here. So this filter, what it does, it removes the ripples from here, and although it does not provide you a proper complete AC here, but a sort of very close to this AC, I get a triangular wave here at this stage. So the function of this filter is to remove the ripples from the output of this rectifier. The AC ripples from the output of this rectifier. Remember that the output of the rectifier is fed to the input as a filter. Now this filter, the input of this filter is provided to a regulator. What this regulator does, that now this regulator, this supplies a regulated voltage. This supplies a regulated voltage so that it can be provided to the load. Now there are certain basics that we'll discuss here. From next lecture I'll start with the rectifiers. So first thing, as I said that about the transformer, certain basics that we'll discuss here. Very first thing, that in our power supply, First thing, suppose this is a power supply, a regulated power supply. First, as I said, that you have a transformer here. You have a transformer here, and first thing we'll assume that the input which is supplied here is a sinusoidal waveform. So this input is sine wave. Sine wave. And suppose I say that this is a sine wave. We'll assume that this kind of wave is here. This kind of wave is here, and this is, suppose I say it is omega t, and suppose I say that this is the voltage V, and the instantaneous voltage V at any instant, this is called the instantaneous value. Instantaneous value means at any instant. Suppose I say that this is omega t, this is equal to 0, this is pi, this is 2 pi, 3 pi. We'll assume that the instantaneous value of this signal which is applied here, or at the output of this V is equal to Vm sine omega t, where Vm is this maximum value, where Vm is the maximum value of this. We'll assume this equation always, that we assume that the input which is supplied to a, which is initially for a power supply, is a sinusoidal signal. It is a sine signal. It is a sine voltage. It can be a sine voltage or sine current, or overall the signal, the function is a sine function having value Vm sine omega t, where Vm is the maximum value. Instantaneous value means at any instant. At this point, suppose I say what is the value at this point, it is equal to Vm sine omega t. Vm means this Vm sine omega t. Omega t is equal to pi, 2 pi, or whatever the value is here. So it is a sinusoidal function which I assume here. And you must be knowing that the RMS value of this Vrms of this sinusoidal signal is Vm upon root 2. Remember that. You can derive this also, sinusoidal, the RMS value of this. So this is the maximum value of this signal, and this is the RMS value which we will consider it throughout our discussion, throughout our mathematical derivations, that we assume that this signal is a sinusoidal signal. And the analysis of any rectifier that we'll do, after this we'll study the first part, that is the rectifier here. The analysis of the rectifier we'll do with respect to the secondary of this. This is called the primary for a transformer. This is called the primary, and this is called the secondary. So we assume that the secondary voltage is, this secondary voltage V is Vm sine omega t, and whatever we'll do, the mathematical derivations are with respect to this secondary voltage, and we'll assume that the secondary voltage is a sinusoidal function, because the reason for using this sinusoidal function is that, or why we get a sinusoidal function is that this function is called a periodic function. If you see that this is here, if you look at this, it repeats after certain time. After this again same type of waveform is there, 2 pi, again 2 pi to 4 pi, again it will the same nature. So in case of a periodic signal, we need to analyze only one period. This is called one period. So we'll analyze only one period, and that will be true for the entire wave from this varying from 0 to infinity. So that's why we use this sine wave here. So from the next lecture, I'll start with the transformer. I'll not discuss that. You already know. You have a step up and a step down transformer, where this ratio, you know, V1 upon V2 is equal to N1 upon N2, and that is equal to I2 upon I1. I2 upon I1. If I say that this is the I2 and this is I1. That is I1 is the current in the primary and I2 is the current in the secondary. So this turns ratio, this volt already you know. So from the next lecture, I'll start with this rectifier with you. Thanks for the time being.